So, here, if we look at fluorine versus iodine, what's the difference? Are they in the same group or the same period? Group. So what are we looking at here? Look at shielding. Which one has more shielding? Iodine has more shielding. So is the attraction between the nucleus and the valence electrons going to be more or less? Should be less. So less attraction to valence electrons. And if it has less attraction to valence electrons, will it take more or less energy to pull an electron off? Again, fluorine, we're looking at your nucleus. So here's fluorine. You have two, and then you have your valence shell. Okay? So how well does fluorine attract to this nucleus? Versus iodine is in group, or it's in period 1, 2, 3, 4, 5. So you're looking at a nucleus with 1, 2, 3, 4, 5. So, which one's going to have more attraction to the valence shell? Fluorine. So does that make it easier or harder to pull an electron off if it has more attraction to it? Guys, easier or harder to pull an electron away from something that's holding onto it tighter? Should be harder, right? Fluorine has more attraction here. It makes it really hard to pull that electron off. So in terms of first ionization energy, fluorine should take much more energy to pull an electron off. It has a much higher first ionization energy than iodine. Much higher. Why? Because iodine has so much more shielding. All this shielding makes it easier to pull this electron off. Questions? Let's try this one. Which one has a larger atomic radius? Is it carbon or oxygen? Make your decision. Go to that side of the room. So let's take a look at this one. Everybody look at the board. Carbon has how many protons?
6.
It has 6 protons in its nucleus. And it has how many electrons total? 6. So 2 in the first energy level, 4 in the second. So here's carbon. Oxygen, on the other hand, has how many protons? 8 protons in the nucleus, 2 electrons in the first, 6 in the second. So, if you look at the attraction between the nucleus and valence shell, which one has more attraction? Carbon or oxygen? Oxygen has 8. It has a much higher ENC than carbon. It has the same amount of shielding. They're in the same period, so they have the same amount of shielding, so shielding isn't a variable here. So if we look at the ENC alone, carbon will have this much pull on its valence shell. Oxygen will have this much pull. So because oxygen has more pull, it has a smaller radius than carbon. So all of you are correct. Carbon has a smaller atomic radius. Sorry, has the larger atomic radius. My bad. All right, make a decision. Which one has a smaller electronegativity? Oxygen or sulfur? Go. All right, here we go. So, look at oxygen, look at sulfur. Are they in the same group or the same period? Same column, so same group. Again, electronegativity, pulling power of your atom on electrons in a bond. So how well does your atom pull on those electrons? Well, if we look at oxygen, we have our nucleus, and we have 2 electrons in our first energy level. And then here's our valence shell right here. If we look at sulfur, here's our nucleus. We have 2 electrons in the first, 8 in the second, and then here is our valence shell in the third. So here we are looking at the shielding. Which one has more shielding? Sulfur. Sulfur has more shielding. So because it has more shielding, it has less ability to pull on electrons. It has less attraction to electrons because of the increased shielding. So here, the smaller electronegativity is indeed sulfur because it has more shielding than oxygen. Very good, all of you. Very good. All right, next one. Smaller atomic radius. Aluminum or boron? Go. So, aluminum, we have more shielding for aluminum. We have less shielding for boron because they are in different periods. So because boron has less shielding, it has a smaller radius. So again, we have our nucleus. Here's one layer. Here's the next layer. Nope. Boron only has, boron has 2 in the first and then 3 in the second. And if we look at aluminum, we have 2, 8, and there's our valence shell. So more shielding for aluminum. Aluminum has a larger radius than boron, so the smaller radius is boron. Well done.